Well, hello and welcome to Pre-Calculus 11, and our first topic is arithmetic sequences. So we're going to talk about sequences and series of numbers. An arithmetic sequence is one in which the difference between consecutive terms is a constant. So I have an example of an arithmetic sequence here. If I take term 2 minus term 1, or term 3 minus term 2, or term 4 minus term 3, I get 3. And since the difference is constant, I have an arithmetic sequence. Now just some other notation we're going to use. We're going to use the letter T to represent the term and the subscript to talk about the particular term number we're talking about. So term 1 would be 2, term 2 would be 5, term 3 would be 8, term 4 is 11. And this little subscript we're going to use the letter N to represent, which is going to talk about the position or the term number that we're at. Now another thing we could do is we could look at this situation graphically, and I could look at, for example, the position here, N, and the term value here. So I'm talking term 1, term 2, term 3, term 4, and the value of my term 1 is 2, term 2 is 5, term 3 is 8, and the pattern continues. And you'll notice that what we have here is a linear pattern, which shouldn't be too surprising from your study of linear functions because the rate of change from term to term is constant. It's 3. Alright, the next thing we're going to look at is determining the value of a particular term. So perhaps we would like to know, if we continue this sequence, what would be the 100th term? Term 100. Alright, so what we're going to do is we're going to look at some patterns here. We have term 1 being 2. We have term 2. Now the way we're getting term 2 is we're taking term 1 and we're adding our common difference of 3. To get term 3, we're taking our first term and we're doing 2 jumps of our common difference of 3 to get 8. To get term 4, we're doing our first term 2 plus 3 jumps of our common difference to get 11. Let's just do this one more time. Term 5 would therefore be the starting term plus 4 jumps of our common difference to get 14. So if I were to continue that pattern to get term 100, it would be the starting value plus how many jumps? Well, you'll notice that the number of jumps is 1 less than this value right here. So if we're going to the 100th term, that would be 99 jumps of 3, which would give us 299. So we have a pattern here that applies to all arithmetic sequences, and that is that if we take our starting value, and we add the number of jumps times the common difference, we will get the value of the term we're looking for, in this case the 100th term. And we can generalize this process. So to get term n of any arithmetic sequence, we're going to take the first term and we're going to do n minus 1 jumps, because the jumps is 1 less than this value here, as you can see in all of these. N minus 1 jumps of our common difference d. And this formula is the general formula for an arithmetic sequence. And so just to clearly define our variables once again, d is the common difference. Tn is the value of the nth term. T1 is the first term. And n is the number of terms. So if we're looking for term 100, n would be 100, and we would have inserted that in that position. Alright, so we've looked at one use of our arithmetic sequence formula, and that is to determine the value of the nth term. But you can use this formula to calculate any of the three other things that the variables represent. We have 4 variables altogether, so if you know any 3 variables, you can solve for the 4th variable. And this question is an example of that. We have an arithmetic sequence, and let's just take stock of what we know. We know that the first term is 6. We have a common difference of 4. Now we have this question that asks which term is 110 in the sequence. Okay, so what it's saying is that term something, term n, we don't know the position of 110 in the sequence, but 110 appears as the value of some term in the future, somewhere down here. This is term we don't know. So what we can do is we know 3 of the 4 variables. We can substitute these into our formula. So term n is 110. Term 1 is 6. The actual n value we don't know, which is what we're calculating for. That's the position. So it's n minus 1 multiplied by 4. And we're going to solve this simple linear equation. So we have 110 equals 6 plus 4n minus 4, which is 2 plus 4n. You can subtract 2 on both sides, and if we divide by 4, we're going to get 27. So what we're saying is that 110 is the 27th term of the sequence.